And I'll share this screen here. All right. Everyone can see my answers?
I just see you still.
You just see me still? Oh, that's because I didn't click that button. There we go. Now we can see my module, right?
Yep.
Perfect. What are the functions of a vehicle frame? So this was the first part. It's funny, the questions tend to go in order of the sections in the book. So the functions of a frame. Remember, we have to have something to attach everything to, something to hold the weight of the vehicle loads, right? The load of the vehicle and the weight of all that stuff, the cab, sleeper, engine, all that. And the last and a very important one is to allow flex, but to maintain rigidity. Okay, so to absorb those shock loads and torsional loads, twisting and bending that's happening as it's driving down the road. Okay, so 3 functions of the frame. The point at which the maximum force is concentrated on the frame is what? Does anybody want to tell me?
The MBM.
The MBM, what does MBM stand for?
Maximum bending moment.
Correct, maximum bending moment. Everyone can hear when everyone else talks, right? I guess.
Yep.
Of course they can. What am I thinking? Yeah. So yeah, maximum bending moment is where the force is concentrated. Ladder type frame is made up of, somebody's not muted. I can hear feedback. There we go. You're muted now. A ladder type frame made up of 2 components. So you're going to have frame rails and cross members, okay, of some type. What is the purpose of a cross member?
To prevent loud. Is that how they say it?
Sway. Sway. Is that how they say it? I think that it's going to talk about provide strength and rigidity to the frame. Okay. So it's to make sure that the frame is rigid and strong. That's why you have cross members. Okay. That's why you have cross members, to stiffen up the frame. Not a common frame rail shape. Trapezoid. Okay. I believe a trapezoid looks like this. Turn my pen on. That's a trapezoid. I have yet to see a frame rail that's shaped like that. So that is a big no. We do not have those. The surface between the flanges of an I-beam is called the
Web.
You betcha, the web. You got it. Wow, my writing is really messy on here. The web. The function of a gusset that is attached to the frame cross member.
This one's for the sway.
Yeah, sway, what do they call it though? It's not
Swivel?
Frame weaving.
Weaving, that's.
Yeah, weaving, I did hear it. Yeah, they call it weaving. So a W word. The web, and then the next one, weaving, to prevent weaving. The size and shape of frame components affect the strength of the frame.
True.
You better believe it. That's the only thing that affects the strength of the frame, the size and shape. So, well, actually, sorry, the material also affects it. But yep, size and shape. So the size of it, how it's designed, that'll affect it. Yield strength as it applies to frame materials. What does that mean? How much force you can put on it before it permanently deforms. Let's make sure that's what they're saying. The amount of stress that the material can withstand before becoming permanently deformed. So the key, I say, all right, I'm back.
I thought you had good Wi-Fi.
We were just talking about that, and then it kicked off the internet completely. So at least it kept everybody in here though. So that's convenient. So
Darwin was just getting ready to teach us.
who was?
Darwin.
Oh, right on. All right, so we are still recording. Perfect. I'm gonna share that again and we'll continue on. Where did it stop at? Where did it cut out?
The yield strength.
Yield strength, right on. So yeah, number 9, I said the amount of stress or amount of force. Force and stress, very, very similar words, but the point of it is how much of it can withstand before becoming permanently deformed, okay? That permanently deformed is the important part. This one, next one's pretty easy. Which of the following frame materials would have the highest yield strength?
Heat-treated alloy steel.
You better believe it. Heat-treated alloy steel is going to be the one with the most.
What, not copper?
Copper aluminum alloy is actually the strongest aluminum alloy, but it is not as strong as heat-treated alloy steel. So section modulus. This is going to refer to the components of a frame or the strength of the frame based on. So first you have the, oh, I can't do that. That's not going to work. First, we're going to have the thickness of the flange, right? Height. So here's thickness is what they're saying is the C. Height, width, thickness, and shape. If you look at this picture of the section modulus, it's much better. Way at the beginning here. So you have height, width, the material thickness, and then ultimately they say shape as well. So is it a C channel? Is it a box? Is it an I-beam? Okay, those are going to play into the section modulus. Unsprung weight refers to the weight of the vehicle and its load. Anybody?
False.
That is false. Refers to the weight of the vehicle and its load. Yep, that's false. That would be sprung weight because the springs are what is holding it up. Suspension system must hold the axles in alignment with the frame. This means that which one of these are correct?
B.
B, absolutely. So parallel is two things that run together and never touch. So you want the tires, the wheels, and the frame of the vehicle not to touch, okay? If they run perpendicular to the frame, that would be very, very bad. That would be the tires would be coming out of the frame at 90 degrees. That would be very bad in most circumstances, okay? Number 16, most common types of energy absorbing devices used in suspension. So they're asking for 3, but we talked about 4. What are the 3?
Spring, air shocks, and cushion shocks, or cushion springs.
So leaf springs, air springs, and rubber blocks. Exactly what you said, I believe.
Yep.
Energy absorbing device of a suspension system is released when it rebounds. So this was a question where we were talking about semantics. A little bit, someone had asked about it.
That is true.
It is true. Now, the problem someone had, or why they thought it was poorly worded, and I see where they can come from with this, is the energy absorbing device, that would be the leaf spring, the air spring, or the rubber block, right? Is it released, like does it come out of the vehicle when it rebounds? No, of course it doesn't. It stays there. But that, we just have to not think of it so intensely. We just have to think, when I hold a spring, I compress the spring. When I release the spring, it's rebounding. That's essentially what all that means, okay? That's how we have to think about it. Just don't look into it too deep. Solid mount suspensions are best suited to applications that what?
C.
C.
Yep, definitely C. Operate on rugged terrain. That's where we want that solid mount suspension. Equalizer beams reduce the effect of shock loads to the vehicle frame by what? How much?
50%.
Yeah, 50%. They reduce that movement to the frame by 50%. Axles stabilized against braking and acceleration by what?
Longitude torque rod.
Exactly. Not only just torque rods, but longitudinal ones. Those are the ones that specifically deal with braking and acceleration forces. The transverse torque rod is for what?
Side to side stability.
Yeah, side to side or lateral stability. Absolutely. Progressive leaf springs provide a low spring rate when the vehicle is unloaded and a high spring rate under load.
True.
Yeah, I'd say that's true. Improve side to side stability by distributing side loads more evenly across the entire length of the axle. So that is the transverse torque rods right out of the back of the book there. And yeah, true. So a nice low cushy spring rate when they're unloaded and a higher spring rate under load. The auxiliary springs are going to help support the vehicle when it is what?
Loaded.
Yep, loaded. The spring shackles accommodate the change in spring length as the suspension jounces and rebounds.
True.
Absolutely. Main function of the shock absorber. How would you guys word that?
Prevent oscillation in the springs.
That is exactly it. Prevent spring oscillation.
Oscillation.
The function of the vertical drive pin on a rubber cushion type suspension is to
Prevent side-to-side motion, or there's a word for it, but I can't remember.
that is what it is doing. So it allows it to move up and down, but maintain vertical alignment as well.
That's the word.
The advantage that air suspensions have over other types is that they provide what?
Ride
Hey.
quality.
Yes, ride quality is what we're looking for, okay? Any of these other three, lateral stability, off-road performance, and support for high center of gravity loads, all three of those are some of the slight disadvantages with air ride. What's the function of that pressure protection valve? Let's see, what do they exactly say in the book here? Ensure that safe pressure is maintained in the air reservoir for air brake operation if a leak occurs in the suspension system. Okay, exactly what I said. So that as your suspension, you get a hole in your airbag and it's leaking air out. If it can't keep up, your compressor can't keep up to that leak, it'll shut off this air suspension so you still have brakes. Right height control valve supplies air to the air springs when? Which one of these would it put air into the airbags?
C.
Additional load.
Yeah, as you're loading the vehicle up, that same amount of pressure in the airbags is not going to be able to hold it up. As it loads up and it keeps going lower and lower, the valve will eventually move and add air into the airbags, increasing the pressure, thus increasing the load it can hold up, bringing it to the correct ride height. And why do we have a two-way control valve and dump valve? So why do we have that dump in the dash?
To drop our trailer lower.
Suspension.
Disconnecting or connecting from a trailer. So that is why they have that there. It's also a bonus for us when we're servicing units. We should also be dumping airbags at the end of every day when they park. So specifically in here, they're going to be referring to connecting and disconnecting the trailer. And that's because this section also goes into fifth wheel couplers. And so we'll talk about disconnecting as well. All right, another book in the bag. Anybody have any questions? I have a question. So my downstairs tenants, very briefly there, were playing music quite loud below me. And I just texted them to ask them to turn it down, and they did. But could you hear the music when it started playing?
Nope.
No.
Oh, perfect. Okay, that's good. I think my microphone is very directional, and it just picks up what it's pointed at, fortunately. So that's good. All right. Does anybody else find this tiring? Sitting here just talking, or I guess in your case, sitting there listening to my cool, calm, relaxing voice?
I'm in a trailer, so it gets pretty tight and brutal after a whole class day.
That I feel the same way, that it gets pretty tiring and just brutal. I had to get up a few times and walk around or something, and it's weird. I guess it's going to take some getting used to, especially for us when we're used to sitting in a class. Probably it's what we've been used to our whole lives up until this moment. So, all right, we'll keep moving merrily along. 190102B. Next book we're going to look at, frame and suspension service. Everybody got that out?
Yes, sir.
Perfect.
Do not drill holes in the flange of the frame.
It seems like you've already read this, or you know one or two things about frames.
I did it on my first day.
You drilled a hole in a flange?
I sure did.
Nice. And that was,
Put a bolt in it, you'll be fine.
yeah, that was a learning experience, I bet, hey? Yeah, do not drill a hole in the flange, ever. You actually should never, ever touch the flange with any kind of drill or cutting torch or welder, anything like that. Very rarely, and only under special circumstances will you actually perform any, do anything like that to the flange. As soon as you start putting holes in that, it makes it so weak immediately, and it'll make a point where it can bend and not come back.
How did you fix the frame that you drilled into?
I didn't fix it, but I believe that they ended up getting it fish plated. Quite like, I think it was 16 inches in either direction of the hole that I drilled.
Oh yeah, there is typically, so we'll actually, in this ILM, I'll talk about this, all of these different repair procedures when it comes to frames. So first we'll talk about some of the different
I'm sorry, I'm missing something here. Drilling a hole in a flange or the frame?
He drilled the hole in the flange of the frame.
Oh, yeah, okay, now I see.
Not in the web of the frame.
Flange.
So you can absolutely drill in the web. And one of the very big takeaways from this whole frame discussion is going to be, you can drill and you can modify the web to an extent, to a limit, but you can't ever do anything to the flange. That will, like, I'm not sure who it was who was talking, but, or who did drill the hole in there. I didn't see the name that popped up, but he said then it was 16 inches on either side of the hole. They fish plated it. We'll talk about repairs like that, what you can do if how you go about plating.
I drilled a 3/8 hole in the top of the like in the flange on the top.
Yeah. Yes.
Big no.
Very bad. Yeah, very bad. And you wouldn't think it is, but even that small hole, even one bead of weld that goes across a portion of the flange can weaken it quite substantially. Yet again, there are circumstances where you might have to do that, but it's going to be controlled and under very specific circumstances when that happens. Okay? So we're going to look at different types of inspection and repair. We're going to look at different types of damages that are common that happen with frames. We're going to talk about why they happen. Okay, that's a big one. And then what we do to repair it as well. And we're going to look at the suspension too. So frame inspection and repair, what happens to frames? How do we fix it? Then we're going to look at what happens to suspension and why. And lastly, how do we fix it? Frame inspection and repair. So when we're going through a frame inspection, there's a few things we're going to have to look for. Ultimately, what we're looking at is just the frame itself, okay? Typically, you'll see a lot of other associated damage with this. Like I said, when I was working at the place where we did a lot of collision repair, if something had a frame that was damaged like this, typically there was a lot of other damage that went along with it, okay? So this is called side sway. If your frame is bent right here and you can see where it's bent here and your drive axles are driving in a different direction than the front of your vehicle is facing, you have a side sway vehicle. So I saw lots of accident, collision, or rollover. And let me tell you, when this thing rolls, if this was a tractor that had a fifth wheel here and it rolled over, there's a real good chance you're going to have some damage like that. Or some twist, which we'll talk about as well. Fire. Why would a fire do this? How could a fire do this?
The heat would just wreck the heat-treated metal.
Yep, and it distorts it as well. So the intense heat, for instance, if you had a fire right at this wheel and caught on fire, and this was allowed to get so red hot that all this steel here started getting really, really hot, you could bend it like this, okay? You're changing the characteristics of the steel, and so it's going to want to bend in a certain direction. So you'll have hardened steel here, and it's becoming softer in the middle, and it's trying to pull itself in. So you're going to have bend in there. The other one that I saw that was super common, and which up here, I don't know, there's a lot of these up here, snow plows. So mounted equipment. They mount things on all kinds of things that probably aren't designed for it, and they mount it in ways that probably aren't engineered the best. So snow plows is a big one. Having a side plow on here, dragging that along as you're driving 80 kilometers an hour, it can definitely cause some damage like this. Diamond. So one frame rail has moved ahead of the other one. It's a little bit hard to tell, but in this image that they're showing us right here, so this one is farther back than this one is, and this one's a bit ahead, okay? So this is the diamond or weaving. Remember when we talked about what those gussets are for and they prevent that weaving? This is what it looks like. So the other term we can call it is diamond. Your frame is going diamond shape.
Could that be from getting towed out of the mud by one frame rail?
Hey, look at that. Towing another unit with a tow chain connected to one corner of the frame could exactly be what caused that. Absolutely. So if you look, most of these two, the accident, collision, or rollover, or incorrect mounted equipment, are the same as the last one. The only other ones that are different are, like you say, if I hook my tow chain up to this frame rail at the front here and I give it a real good yank, it might pull that frame rail out of alignment with the other one. Okay, same thing with pushing. If I push from back here, same thing. Okay, you can do the same type of damage. So whoever said that, you're absolutely correct. A twist. a good old twist in your vehicle. Accident, collision, or rollover. This is probably, if you hit the ditch, this is what your tractor is going to look like, okay? If you roll it into the ditch, chances are your frame's going to look exactly like this, okay? You might have, these might be flat on the ground and that left side's going to be off in the air. If you actually do a lot of drag racing with your semi, it might look like this too. So we'll look at some of those videos of tractors, tractor pulls and stuff like that, what the frame does, okay?
Yeah, I was gonna say torque.
Yeah, yeah. If you wind this thing up all the time and it's torqued up all the time, you can definitely cause that kind of frame twist. So even on any kind of drag car, high torque, high horsepower, you pick up trucks and stuff like that when they're pulling a load, you've seen that frame twisting like that. It's essentially the drive shaft is trying to turn that whole axis assembly around, and it's being stopped by the weight of the vehicle and everything. They're all fighting each other, and it's twisting and twisting. So commonly too will cause that is rough terrain operation. So a frame that isn't as strong as it should be, going in places it shouldn't be. Here we go. Here's what we're going to see on pickup trucks as they get older and older, a frame sag. So this one is largely easy to do for operators, especially if they aren't paying attention. Overloading, uneven loading or load distribution, improper fifth wheel installation or improper location of the fifth wheel. So that would be like uneven load distribution. And then things like improper frame modifications or repairs, such as holes in the flange or too many holes in the frame rail, or overheating, so you're changing it, notches or cuts, and welds on the flanges, okay? Any of those cause a spot where it will now bend. A bow is the opposite of a sag, okay? It is a bend in the same area, most likely at the MBM, maximum bending moment, but it's going to be the opposite direction. What can cause that? So spreading a load with a box raised on a dump truck. The other thing I've seen with this one is if they're lifting the box of a dump truck that has the gravel or whatever the load is frozen in the top, and it pulls it down over backwards, okay? I've seen that too. Incorrect use of mounted equipment. Yet again, if this tractor was originally had this fifth wheel on here, and you yard that off and you put a bit of a deck on there with a big winch here, and you start pulling loads that this wasn't designed for, you could end up getting this kind of damage as well, okay? So incorrectly mounted equipment. Liquid surge in a tanker. This is a big one. So typically nowadays we have baffles inside of the tankers to prevent that liquid surge, but it can be a huge amount of inertia that's stored up in those tankers if you suddenly have to slam on the brakes or something like that. And a collision or the vehicle involved with a fire. So yet again, if there's hot concentration of heat in one spot, just like when you would damage the frame with a torch, big fire will do the same thing, cause it to anneal differently, and the properties of the steel will change, cause a bow. There we go, corrosion, everyone's favorite. So this amount of damage, typically a lot of corrosion problems I had came when it was two different metals coming into contact with each other. So you'd have the aluminum with the steel, biggest problem there, and you get that white oxidation, which is aluminum rust, essentially. It's not termed rust is iron oxide, but that's what it is. It's oxidizing aluminum, turns into that white powder. Something like this, you might see because of the conditions it's in. So this is steel breaking away. Who knows what kind of caustic powder maybe is inside of this trailer, or corrosive chemical or basic chemical. The other things I've seen are different types of biological hazards. Now, we don't typically think of biological hazards, but if you work with any kind of cattle, that's a biological hazard that can be quite corrosive as well. So I've I used to fix a lot of Lilydale trailers, so they haul chickens, live chickens, and that chicken poop is very corrosive. And you can have a trailer that's only a few years old looking like this, where it's got underneath and it's bubbling up and there's holes in the steel from the corrosion. So good way to check your corrosion is walk around with a pencil just like what he has here. I even used to take a hammer and you just go lightly around tapping the frame. You should be hearing a nice steel noise, right? We all know what it sounds like when you hit on steel. If you start hearing a dead spot, you might want to take your pencil and you might even be able to poke through there. I've had lots of frames that would look like this. And if you start poking, you can poke holes right through the web on them, which is very bad, very, very bad. Cracking obviously is very bad. So in the frame rails and cross members, that's usually a sign where you'll see where loads are happening or even excessive loads. So right here, this device here is called a load binder or a ratchet. It essentially, it's on the sides of the trailers down the length of a deck. And this is what you could use to ratchet your straps on with. So it's a high tension area. You're gonna have the force of the ratchet is in here, and this wraps up around the load and then to another one on the opposite side. So it's pulling out this way quite hard. So if you start getting corrosion, this is where you could start getting those cracks. Okay, any of these load bearing areas, good to watch out for cracks.
Just like our 45-ton pickers, right where the picker sits and then the walking deck, there's always cracks right there, almost on the older ones almost every year, and it's the same crack that they weld every year almost.
And that would be, that's the maximum bending moment. That's the point on that picker, right, on that truck where the most force accumulates. And obviously right where the picker attaches, you have that long arm going out and picking up loads and moving it around, dropping it off. That makes perfect sense. So how do we measure for those first few different damages? So we're looking for side sway or diamond, okay, is what we're going to be looking for this way. We can take our frame and we're going to take different marks on the ground. And this is actually something we will get to do in shop, is how can we check a frame to make sure it's okay. So you want to take as many points as possible. The more, the better. You want to make sure they're evenly across as well. So if I'm using the mount for the front pin, spring pin on that side, I want to use the same point on the same mount on this side. I wouldn't want to pick, so let's say there's an air dryer here and a fuel tank here. I wouldn't want to pick the mount for the air dryer and then the mount for the fuel tank, because that's not going to be a very good spot to measure things that are even, right? You need to pick things that are designed evenly. Another good spot to do is cross members. So like the bolt hole for here on that gusset should be the same as the one on the opposite side, ideally, okay? And then in that case, you can have and check another additional spot, okay? The more spots you check, the more accurate this will be. And what we'll end up doing is exactly what they say under here. We're going to take pieces of paper under all of these different spots. We're going to use a plumb bob, which is just a string with a really heavy weight on it. Okay, that's going to hang down. We'll hang it at each one of these spots, transfer a mark onto the floor. We're then going to be just like what he's doing here. So you see he picked this portion to measure from. You're going to do the same on the opposite side. Transfer it onto the floor. Once it's on the floor, you can move it out of the way. Then you can start measuring. Measure your chalk lines. So they want you to put these lines on the floor, and that's what we're going to do. We'll put chalk lines down on the floor for all the points we've measured, and then we can measure distances. So this distance here should be the same as this distance here. And if they're different, we should be able to tell what is happening to the frame. Now, is there a better way to do this? Yes, there is. But you need to work at a shop that does frame repair, because it requires a great amount of skill and knowledge to properly repair frame assembly so that it will continue to provide safe and effective service. Now, where I worked, we did a lot of frame repair, and we actually had a frame bending bay. So we had the ability to measure and bend frames without doing this. So they do make proper measuring tools to measure all of these components with lasers. It's a lot more complicated, and you get the same result. Now, the difference is I could do something about it. Typically, if you go into your shop and you measure a frame and you find that this is the damage it has, you're probably not going to be able to repair that, or this either, right? Most likely you won't be able to repair this at your shops where you are, unless you have some very specialized equipment or some people with some very good knowledge and skills. You do need to know what you're doing when you're repairing these, or it's just going to bend again and it'll be the same. And then why did you bother even trying, right? So, and depending on if you're at a fleet, that might be okay, right? If you're at a fleet, sometimes they're like, well, let's give it a shot and fix it. Whereas if somebody's footing the bill for a frame repair, which could be very expensive, and then within a week it's back the same, that's big problems most likely. Okay.
I got a buddy who, him and the people that he works with, they actually replaced both frame rails on a tri-drive. It took them about a month because they just had a couple first years making sure that everything was unhooked and everything, and like grinding off the hook bolts and everything, and they actually replaced both frame rails.
It's a big job. That's a big job. I've plated 2 complete gravel trucks from front to back with one piece of channel. And so it's very similar to that. We didn't replace the frame rail. All we did is you disconnect everything from the frame, and then essentially from the back to the front, you slide in new lengths of frame, all the entire length. And it went from an inside C channel to an outside as well. So for each frame rail, it had 2 pieces of plate, one on the inside, one on the outside, and then every hole needed to be re-drilled on both of those. So there's 4 additional rails with every hole to mount everything. And yeah, it's about that long. It's a full-time job.
I was just gonna ask, so when you worked there, did you do any repairs on like really heat damaged frame rails, and is that what you would have done to fix it?
Chances are with a trailer, it's easier to replace it completely. There's a lot less components on a trailer. With a tractor, it takes a little less time and it's a little easier to just slide it in. Now, it ultimately depends on a lot of it. When you're working with collision damage and heat damage like that, it's to do with insurance. First of all, how much is the damage going to cost versus how much insurance is going to pay for? And then the other one is safety. If we guarantee that it will be as strong as it was before? Because that's what insurance is guaranteeing, right? They're going to warranty it that it's original. It's just as good as it was before it was in this damage. And heat damage is tricky because you typically will need to bend it back and then reinforce it. Okay. A lot of times once it's heat damaged, you have to replace it or reinforce it. You can't just bend it back. Whereas something like a bend, if it cold bent, you can bend it back and it should be okay as long as you're bending cold. Does that answer your question?
Oh yeah, that's awesome.
So, and bending the frames back, like any of these sags and bows and anything like that too, in order to fix them, if they're just a cold bend or it didn't happen because of heat, you can bend it. It just takes very special equipment to do it. can push it around. So when we're talking about how we attach things to frame, here's a warning that apparently, I don't know who it was who drilled in it. They didn't read this. They didn't see this on there at the time. Do not cut, weld, or drill frame rails. So they're just talking about at all. Do not do anything to the frame rails without looking in this service manual, okay? It's very important to follow. We talked about these already, or someone brought them up. Huck bolts, so frame fasteners. The most common ones you're going to use are just grade 8 bolts, okay? The other ones you're going to see typically from the manufacturer is going to be Huck bolts. It's a brand of locking bolt. They're a lot like a rivet or a collet rivet, okay? They hold them really, really tight and they almost never loosen off, okay? There are times if you do have to get aluminum with steel, definitely use some type of special anti-seize. Or what we had happen is an entire series of aluminum deck trailers came back with problems, bad problems of corrosion, and the fix from the manufacturer was duct tape. So it was take the aluminum deck off, put duct tape on the top of the flange and then of the steel subframe and put them back together. And that's how you prevented the contact between the aluminum and the steel. So Huck bolts are awesome, exceedingly strong, and do not allow movement or flexing. They are great, except they're only one-time use and you got to take them off. Now, does anybody take them off with this? No, I know what people do to take them off. You take a torch and you go right in here with your torch and you burn them off right there. Or the other side. With what we've talked about, could you see how this might be a problem?
Oh yeah.
Fire. Now, do we still do it? Yes, people do it every day. Are you damaging this frame? Well, it depends how good you are with the torch.
I was just gonna say that. Depends how good you are.
So, exactly. If you have to spend 5 minutes heating around here before you blast this with oxygen and blow that collar away, you have definitely heated up all around here and probably made some problems. Now, if you're good at this and you were quick with the torch, chances are you could have heated this up and cut this collar off, and you could still use every single one of the threads on here. So it just depends on your skill with the torch, and that's something that'll come with time. What I will say is Huck, the manufacturer of Huck bolts, suggests taking it off this because this is how you guarantee you're not going to damage the components, okay?
What about a plasma cutter?
A plasma cutter would do the same thing. You have less chance of overheating, but you put quite a bit of energy in there quite quickly.
Yeah, it still gets pretty hot.
The problem with a plasma cutter now, so when I put a plasma cutter in here, it goes in however deep it's set up for, no matter what, right? It's going to cut into here and it might nick part of the frame as well, okay? So a plasma cutter is probably even worse than a torch. I've never used one to take Huck bolts off. I'm not going to lie to you. I've used plasma cutter lots, never to take Huck bolts off. Now, what I have used to take those off is my air hammer or a torch. Okay, typically that's what it is. Air hammer with a chisel. You're chiseling off this collet, break it away, and then the bolt will pound right out, or you're cutting with a torch here as quick as you can, get that off of there, and then pound the bolt out. Okay. So I've never tried plasma cutter. I mean, it's a metal remover, right? Who knows what an air arc is?
Yep.
Carbon rod. So it's
Loud as hell.
Yes, it is one of the machines that will make you lots of friends in the shop. The other one is your air ratchet. Everyone loves you when you have your air ratchet out. So the air arc, it's essentially, it looks like you're stick welding, right? You have a stinger, has the cord. There's going to be another air line on here and then an air nozzle. So air is blasting out from here, and then you have a large carbon rod. Wherever you strike that carbon rod, it just burns the steel away and blows slag all over the place. It's really, really loud because of the air going through it, and they work great because anywhere you touch it, it will erase the steel and burn it away. Yet again, you have to be very skilled to use it too. It's very easy to gouge out sections, of the frame with that.
What was that called again?
It's called an air arc. Or essentially it's
Is it called like a lance or something, or is that way too big?
So a lance is a bit different. That uses like a burning rod that's attached to a battery. It might also be called a lance, but an air arc, I'll look into that one more on exactly what the terminology is for that air arc. The air arc is a brand.
I don't know. I've always heard it being called an air arc too.
Yeah, that might be the brand, but essentially it's just a different stinger that goes on your stick welding machine, and that has an air outlet on it, and then it takes a special rod that instead of being weld with flux, it's carbon, and it just makes intense heat. Like you have to turn your welding machine all the way up, essentially, and it uses that really high amperage to burn the steel away.
A thermal lance, I just looked it up. It looks like a 4-foot long air arc.
Okay, so that's just a big air arc then. Like these things, you can plunge them into steel and it will just make molten steel fly out at you, right? Like you can, what we used to do is when you'd have a kingpin on a steer axle that sees, so that's the very large shaft that goes inside the bore in the axle. When those got seized in, you would just take an air arc and you could just sink it right through the center of the kingpin, and that would loosen it up really easily. But you had to be careful not to hit the bore on the axle, the bore for the kingpin, because yet again, if you weren't going straight down, any metal that touches it turns to liquid. It's no forgiveness whatsoever.
What we've used it for is those mounts, those Y torque arms. They have that mount on the diff, and so those mounts are those torque arms. If a bushing wears out in the middle, it just starts smacking those sides, and they can crack and bend. So we have to air arc the mount completely off, and our guy has to line everything up and re-weld it back on.
A new one, yeah, absolutely. One thing I loved the air arc for is changing dolly legs. If you had a way to support under the nose of the trailer, so it was on dolly legs, and well, I need new ones, so I'd support the front of the trailer, just lift it off the dolly pads just that much off the ground. You could essentially arc off the old dolly legs, leave all of the brackets still attached, and then you just bolt on the new ones and then just re-weld the brackets. So it has its purpose and it works really well for what it does. Yet again, take some practice to get skilled with it, just like anything. We're mechanical artists. Okay? All the things we do require skill. As some of you have seen now at making those hand tool projects, right? It takes some practice to do this. So if you have a frame that's diagnosed as side sway, diamond, twist, sag, or bow, it may need to be straightened. So you would take it to someone like me and we'd put it in our frame bay that looks a lot like this. So we have a special contraption that has a very powerful hydraulic or air-powered rams on the side, and that can also be mounted on the bottom. And these are what would be pressing on the frame rails. Now you can see these channels in the ground. They're essentially just I-beams that are cemented into the ground. All we can see though is the top flange. So what you would have in the floor, it would look like this. Almost like how train tracks are. So you'd have your I-beam. This is the I-beam, and the floor would be cemented like this. And then what you would do is around these areas here, or when you're bending on the frame, you would have little pieces. So I would have a half piece. It has a hole in it right here, and it would be a hook like that. Then I'd have a corresponding one that would go on the upper side like this. And then I could run a chain through here, wrap from here, wrap it around the frame, and then the frame is attached down into the bay here. And then you attach the different types of pushers on there as well, right? So let's say if this frame was sagged down like that, I would have one here, and I'd put another one down on this side over here, and then I would push up. So these would hold it still, and this would bend it back up then. Make sense?
You bet.
So yet again, if you don't have these types of devices where you're working, you're probably not going to see this kind of stuff. We had essentially, you have to know how far you could bend something. If you've ever bent a spring steel, especially, and frames do have an amount of springiness to them, you have to bend it farther than where you want it to stop, essentially. And so there is a process involved with it. I also worked at a suspension shop, and so we used to rebuild springs, and you'd put the arc into a leaf spring. So it's the same type of work. It's touchy though, because if you start bending it too much, then you start work hardening it, and then it's going to become brittle and it'll fail anyhow. So crack repair. So underneath of this reinforcement plate, there might be a hole, 3/8 hole right there that you drilled. There might be a crack, or there might be a break in the frame. Now, if there's a break in the frame, a special way you reattach it. So let's say I wanted to shorten this frame, and this is where I shortened it. This is going to be the back section of the frame, and this was the front section. I cut out this middle and I wanted to attach them. What is it going to look like under this plate?
You would cut it on an angle instead of a straight up and down.
I agree. So it would be at an angle. Why would you do that?
Increases the surface area of the two mating pieces.
It sure does. Yeah, and distributes the load evenly. So loads are going to be going up and down on this. So you're going to have loads going like this, and you're going to have loads going like this. Okay. If you had this crack, if it was, instead of looking like that, it was straight up and down, and you attached them, butted them together and welded them up, and then put this flush plate or reinforcement plate over it, as soon as it hit a bump, it would break here. This is where it's going to break. You have a lot less area of contact, and you've caused one specific weak spot in the frame, okay? So what you would want to do is you'd want to have it at an angle like this. So now any load applied to this specific length of the frame is transferred a longer distance, and it isn't ever concentrated on the entire length of the break, okay? You can see here it's concentrated over just this one little portion of the break. The rest of it is all solid, and it's distributed over a larger area. And the reinforcing plates too, I would say they're going to look different depending on how you're going to install it. If you're doing this, you're going to be looking what the manufacturer and what engineers are telling you to do as well. It's not just going to be, most of the time, it's not just going to be throwing one on without any foresight. Causes of suspension system malfunctions. So this one goes through pretty quick because a lot of them are very common. What would cause your vehicle to lean to one side? And now we're not talking about the frame anymore. Now we're talking about the suspension. What would cause this?
Cab airbag.
Yeah, airbags, yeah. Often what I would see with this too is a worn out leaf spring. So sagged or fatigued leaf spring, or a broken one on a steer axle will make your truck sit funny like that too. So air system problems. If you have an air suspension, misadjusted ride-height control valves that use 2 of them. Remember I said there's some that'll use 2? That will look like that. You'll be driving down the road constantly sideways. Those valves are misadjusted, or even if the height control rods are misadjusted. Leaks as well can cause that, leaks on one side, or if your air comes to each side from a different spot, low air supply on one side, so a faulty pressure protection valve might be causing your problem as well. Wandering, so if you cannot keep this thing on the road, or while you're driving down the road, we've probably seen those trailers where the vehicle is driving perfectly straight, but that trailer is just going back and forth like a dog's tail, okay? So that's a wandering tractor or wandering trailer. So frame misalignments, damage, improper steering alignment, or faulty steering gear can contribute to these, okay?
Weight distribution.
Yeah, improper weight distribution, because what'll that do? That'll make you sit like this, right? If you improperly distribute the weight, and then you're going to be trying to turn one way or the other. So absolutely, improper weight distribution will do that as well. Okay, for leaf springs, especially drive axles out of alignment or broken leaves, that'll cause you to wander as well. And air suspension, pretty much all the same things with an addition of out of alignment. Bottoming out. So bottoming out is when we go to the complete bottom of our suspension. So remember I said in here we have these little rubber bumpers. That's when you bottom out, when you dump your airbags, that's where they're going to sit on, okay? What can cause that in leaf springs? Overloading, broken or weak springs. Overloading is probably the most common one. And it's probably something all of us have seen at one, time or another as well. Right, the more we can fit in our unit, usually the more money we can make, or that's what our thinking is. And an air spring, what could cause that bottoming out? So low system air pressure. If we can't build us that 70 psi, our airbags are never going to fill up, which means we're going to be bottomed out. So excessive leakage, a leak in the air springs, misadjusted height, or ride height control or dump valve aren't working properly, okay? All of these, essentially, no air in the airbags. What could cause no air in the airbags? Frequent breakage. So our leaf springs are breaking quite constantly. What would do this? Well, the one thing that I've seen the most is U-bolts. Loose U-bolts will break the spring very, very quickly, okay? When we look at a leaf spring, we often think, so we have a leaf spring just like that. We can have our axle on the top or on the bottom. So we'd have an axle like this, nuts here, holding them on. We can also have it on the top, like this. So there's a few different ways that we can have the U-bolts aligned. Now, Loose U-bolts will break a spring because we think when we see this leaf spring that it's like a bow. It's not necessarily. The whole spring isn't designed to flex all the way through. It's actually designed to be clamped tightly right here and here. And so only this side will flex for this side, and only this side flexes beyond here. It is supposed to be held tight. If it's allowed to move inside of here at all, you're going to get breaks happening. That's how things like this can happen. Loose U-bolts is
So that's like overworking the metal and then getting hard and brittle.
it's essentially what you're doing is you're making too long of a lever. So they're designed that this is supposed to be the effective length of the spring. If this one's loose, now all of a sudden this front section here is a lot longer. So the force applied here is causing a lot more force to be generated here, just because it's not held here anymore. Oh, it's really piling on here, sorry. Because it's not held here anymore. So this is able to move and it's only held still here. If the whole U-bolt side goes loose, it's gonna break very quickly. It'll just flap around and yeah, it'll break very quickly. So it's not necessarily that it'll cause work hardening, it'll overload it, and that's how it'll break, I guess, which will eventually cause work hardening if it stretches or starts bending beyond its yield point. So different noise. It should make very little noise. Now, that being said, unless you hear an abnormal noise, I wouldn't necessarily go by noise, because I can show you a few vehicles that are really noisy. If you've ever listened to an 8-bag system when it's airing up, it makes a heck of a lot of noise when all those bags are going up. It's creaking and moaning. And sometimes things that have spring suspension too, when they're driving around, they actually make quite a bit of squeaking and squawking as those springs are bending and flexing, okay? What can cause a rough ride? Frame is bottoming or improper tire inflation. So rough ride is probably one of the things you'll hear about most. The complaints you'll get when it comes to this is, I can't control it and I have a really rough ride. That's typically what you're going to hear when it comes to these. And how do we repair the suspension? Well, very carefully, because it wants to kill us. There's lots of difficult components in here to repair. First thing, I'd clean everything, and you're going to see I'm going to say that all the time. Anytime I have to repair something, I would like to clean it. Actually, anytime I'd want to inspect it, you're going to want to clean it. Some places will allow you more time than others, but in all honesty, if it's not clean, how are you going to see what's wrong? Okay, that's the bottom line. And then repairing something that is just covered and disgusting is no fun either, and it just adds time. Okay, cleaning, very important.
Should tell that to my bosses. They probably wash stuff like once a year, maybe.
And unfortunately, some people's minds are hard to change when it comes to that. So yeah, it depends on where you work. So I was very fortunate to have one fleet where we had an automatic truck wash that you could fit a tractor and a Super Bee in, and so we could wash anything very easily. It was fairly nice. So, what are you going to look for on your leaf springs? U-bolts, center bolts. So what are the center bolts? Your center bolt is what is inside of your leaf spring. So inside of it, right here, holding all of these leaves together. So you have leaf and a leaf and a leaf. Inside of it is called a center bolt. So it's a special bolt with a round head on it. And if this one breaks, you're also going to start breaking leaves, okay? If this bolt breaks, it's actually, I would say, a symptom of loose U-bolts as well, because that's when this center bolt is what's essentially trying to stop the deflection of the spring. How will you be able to see if that center bolt is broken? If you have the leaf starting to come apart. So like if this top leaf has shifted over this way and you can see an inch of the top of this bottom leaf, you probably have a broken center bolt and some very loose U-bolts as well. The other way you'd see it is if they start rotating. So when you're looking at the top of the spring, typically it would look like this, right? And here you'll have your eyes on either side. If you start being able to see the other leaves sticking out from the bottom, chances are your center bolt is broken and they're starting to rotate out, okay? The other thing that can cause that is if these clips are broken as well. That can start causing that to wander out.
Yeah, we've had those happen. Just those clamps always, or they'll break or something. I've tried to like put them back on and do something, but nothing works. They're pretty much just
Fuck. You more or less have to take the spring pack out and recompress it to get them properly back in there. So the spring assembly itself, so very important, make sure that nothing's shifted or loose and there's no broken leaves in there. And the shackles and pins, make sure they're not loose, cracked, broken, or excessively worn. So here's what we're gonna do. Oh, what happened? There we are. I glitched out. Because I want to talk about all of this more than the next 20 minutes allows. What I would like is today, read the rest of this book. Please also flip through 102C and D, because tomorrow we will try and go through as many of those as we can, all right? So please today do the rest of this book, do the self-test tonight, and also I'd love it if you could look through 102C and D, and we're gonna look at all of that tomorrow. Does anyone have any questions? I've been talking for what feels like forever for me, so does anyone have anything while I say?
Quiz.
No quiz. Or wait, what do you mean by quiz? Like, you can please do the self-test, okay? Definitely do the self-test. If quizzes are gonna come, there'll be an announcement posted and you'll know about it. Don't worry, it won't be a surprise or anything like that. You'll know before it happens.
Nice.
Anybody from, or anything from anybody else?
Don't think so.
Don't think so. All right. Well, I hope you all have a good evening and you can get some reading done. Just so you all know, I'm just like you've found so far, I'm available. If you're reading this and something doesn't make sense, shoot me a message, an email, call, text, whatever. And I'll try and answer your questions as soon as I see them, okay? So other than that, have a good evening. And I will see you 8:30 in the morning.
Thanks. See you later.
Yep,
See you
have a
later.
good
Thank you.